Hey y'all, this is Notes 36, solving trig equations, right? So to solve needs to find all the possible values to make the equation true. So that's our goal for today. We're going to be working with degrees since it says assume that theta is in between 0 and 360 degrees, so one full circle. Our basic strategy is going to be this. We're going to set it equal to 0 if we need to, right? And we're going to need to if we need to do some factoring, if it looks maybe something like this. We're going to draw all the possible triangles and find angles. So for this first one, since it already just says tangent theta equals 1, we can go straight to our triangle, right? So in this situation, we don't need to set it equal to 0. We don't need to factor it because it already just has a trig function equals a number. So I'm going to go ahead and draw possible triangles. Remember, tangent, we've been practicing this in our reviews for the last 2 lessons. Tangent, remember, is y over x. So for 1, we could have 1 over 1, or we could have -1 over -1. Both of those would simplify to this here. So where is my y negative, or where is my y positive 1 and my x positive 1 would be in this quadrant here, positive 1, positive 1. Where is it -1, -1? It would be over here, -1, -1, right? I see these are 45, 45, 90 triangles, right? So I've got 45 degrees here, 45 degrees there. I want to find both places where this is true. So the first one, 45 degrees, and the second one goes all the way around. That's 180 plus 45 more would be 225 degrees. Okay. So those are my 2 answers for this type of problem. So this is really more of a review, right? If you are still like thinking this is pretty challenging, you can check out number 33. That's what we've been reviewing. Today, we're going to take it a step further by factoring it if necessary. So we're going to set equal to 0 if necessary. It's already equal to 0. We're going to factor if necessary. So see in this case, I have cosine squared, cosine, and 2. I want you to think of this problem as like x squared minus x minus 2. If you think about it in this way, you can say, okay, I need 2 numbers that multiply to get -2, add to get -1. It'd be like 2 and 1 with the -2 in front. So this would translate to x minus 2, x plus 1, like that, right? This section would turn into this. We're doing the same thing here. Notice the structure is the same. So with cosine squared, we have x squared. We have minus x minus cosine, -2. Right? So this is really turning into cosine x minus 2 and cosine x plus 1. Cosine x minus 2, cosine x plus 1. If you did the box, this is kind of a wild box. Cosine x minus 2, cosine x plus 1. You get cosine squared x minus 2 cosine x plus 1 cosine x, and then minus 2. These would combine together to give you the negative cosine. You got cosine squared, you got minus 2. Right, so you can see these here, right? If you put them back in the box, you're going to get back to your original. That's how you know you did it correctly. All right, so now that it is like this, right, either of these could be equal to 0. So we really have like 2 problems here. We have cosine x minus 2 equals 0, and we have cosine x plus 1 equals 0. Right? Now that they're like this, we're very close to this format. That's our goal, to get it in this format. So I'm going to move the 2 over. Cosine x equals 2. And then move the -1 over. I get cosine x equals -1. All right. So we set it equal to 0. It was already there. We factored it. We're going to draw the possible triangles and now find the angles. So I've got a triangle here. Remember that cosine is x over r, right? X over r. So we have over 1. My first thought here is, well, my r should be my longest side, right? And x is bigger than r in this case. So this is not a possible triangle, right? Not possible. Not possible. If you think about it in a different way, we had like 1, 2, square root of 3, right? And then we had the other sides are 1, 1, square root 2. And our x in both cases either 1 or 2, but our this is not our radius. Sorry, I actually wrote this wrong. This would be 1 square root of 3, 2. These are our possible values for our radiuses. And these are possible xy's here. This part. So this is not possible. For our other one, we have cosine x equals -1 over 1. So we could have, this is our x, this is our r. So our r is positive 1. The only place where this could be, where x is -1, is over here, right? Where our x and r are the same. So -1 is our x, r is our positive 1. And that angle, if we're talking about this here, is 180 degrees. All right, so our possible answer, our only possible answer here is 180 degrees. A little wild, but probably more likely that more impossible ones come up on these. Let's check out our next two. All right, I see 2 cosine squared plus cosine. So I'm thinking, what if this was 2x squared plus x? What do these have in common? They have x in common, so take the x out, and I'd be left with 2x plus 1, like that. Essentially, both of these have a cosine in it, so I'm going to go ahead and take that cosine out to the outside. So I'm thinking here, okay, I would take cosine to the outside, and what would be left over? This would have 2 cosine left inside, right? If we just took away one of the cosines, we divide this by cosine, we get 1. So here we have our 2 problems. We have cosine theta equals 0, and we also have 2 cosine theta plus 1 equals 0. The first one goes straight to our triangle since it's already cosine theta equals a number. Number cosine is x over r, so my radius is 1. So my x is 0, my radius is 1. So possible places where that could be, x is not left or right, just up or down. My radius is 1, so it could be here, right, where I have x equals 0, radius equals 1. And then I also have here, if x equals 0, radius equals 1. So that first part, 90 degrees. And also all the way around to here, 3 quadrants, 270 degrees. So those are 2 of my answers. Let's see if there are any more here. I think I subtract 1. I get 2 cosine theta equals -1 divided by 2. So cosine theta equals -1 half. Mark these on top of each other. -1 over 2. So I have x over r. Go to my triangle here. All right, my x is negative, so I'm going to be over here, -1. That means I have y's of square root 3, so my radius is going to be 2, which means this is a 30-30 or 30-60-90 triangle. The -1 is down here, so I would really have, so this has to be 60 since it's across from the square root of 3, 60 like that. So I'm going to go up here. So the whole thing would be 180 minus this 60 would be 120 degrees. Okay. And then if I'm going all the way around, this would be 180 and then 60 more. would be 240 degrees. 240 degrees. So my other two answers, 120 and 240. So there are 4 solutions here. 4 solutions to this problem. Okay. If I was to plug in 90 degrees in here and calculate this, I'd get 0. If I put 270 degrees in here, I'd get 0. If I put 120 in here, I'd get 0. If I put 240 in here, I'd also get 0. So there are 4 total solutions to this type of problem. Oof, kind of crazy. All right, let's try one more. So we have tangent, and a number. You might be tempted to be like, oh, I can take tangent out of here, but remember we have to set it equal to 0 first. So I'm gonna flip this over here. Tangent squared theta minus 3 tan minus 4 equals 0. Think about it like x squared minus 3x minus 4. Negative 4, negative 3. Could get 4 and 1. Negative 4, positive 1. So this is x minus 4, x plus 1. So when you go here, you're going to do tangent x minus 4, tangent x plus 1 equals 0. Something like that. All right, so we have two solutions, or 2 possible equations to solve. Tan x minus 4 and tan x plus 1. I'm going to move that 4 over. Tangent x equals 4. Can't think of anything that would have 4, right? Like 4 over 1. That's not going to exist because that's not one of our triangles. Remember, we had 1 square root of 3, 2, and 1 square root of 2. Right, so 4 doesn't exist in any of them. So there's no solutions coming out of this. Right? And then our other possibility here, I'm going to move a 1 over. Tangent x equals negative 1. This will be over 1. So tangent is y over x. So I have either negative 1 over 1 or 1 over negative 1. So my y is negative. My y is negative. My x is positive. So for here, 1, negative 1, or over here, 1, negative 1. This is 1 square root of 2. So we know we have 45, 45, 90. So you have 45 degrees here, 45 degrees here. So this distance, 180 minus 45 would be 135. And then this other distance all the way around, everything in the triangle, 360 minus the 45 degrees would be 315 degrees. So we'd have 2 answers from here. We'd have 135 degrees and 315 degrees. No solutions coming out of this one. So we just have 2 solutions for the D equation here. These are really challenging, guys, so we're just going to try them. That's the best. So you have 4 here that you are just factoring, right? Just factoring, just that first step. And then you have 5 here that you are attempting to solve. I put a little hint about how many solutions there are, so you should be able to figure out just by process of elimination what your answers are, so that it can feel a little less. You know that if you got one of these answers, then you're good to go. There is extra credit here if you'd like it. You're welcome to work on the ACT. So that is it. I will see you all on the next time we're together. Thanks, y'all.